Welcome back, friends and neighbors, to more networking goodness. We are about to go through a series of multicast videos, and so I don't know how many I'm going to do, but we'll just call this number one for right now. Alright, so the reason I'm doing another video for you, another series of videos, is because I've decided to write a couple of more chapters for the Packet Guide to Routing and Switching. And this is a set of ideas or set of concepts that some folks have asked me to add. So here we go. So again, this will be in addition to the Packet Guide to Routing and Switching. That's the second book that I wrote for O'Reilly. So let's multicast. So when we do a little bit of multicasting, we have a couple of things to consider. We're going to start with addressing, but then there is the whole idea of what does multicasting do to your network? Where do we use it? Things of that sort. Multicasting for most network administrators, particularly when we're talking about a routed topology, is a pain. And then there are differences between IP version 4 and IP version 6. So let's tackle addressing first. Now to begin with, there are a couple of flavors of addressing. We've got unicast, it's you to me, multicast, me to a bunch of folks, and then there's broadcasting, me to, say, everybody. Here's the thing. Multicast addresses are designed to get to a subset of everybody. So we might be after a particular protocol like spanning tree. We might be after a particular set of recipients like those interested in a multicast stream. Some vendors use multicast to talk to their gear and routing and so on and so forth. So there's lots of reasons that we want to get to a subset of all of the nodes on the network. Now, by default, multicast addresses go everywhere, just like broadcast. That's because we're not really sure where everybody in the group is. So we'll see later on how we sort of solve that particular problem. So this means that multicast addresses are are forwarded everywhere, and that can mean a lot of network pollution for your topologies. So when we dive into addressing, there's really two really big things to remember. There's layer 2 and layer 3 addressing. So usually whatever happens at layer 3 is reflected in some way at layer 2. And then we've also got IP version 4 and IP version 6 versions of this. And so it doesn't really matter what time frame you're looking at. You've got this multicast out there, and it's going to go forward. And in fact, IP version 6 uses a lot of multicasting. So the standard waddy-wah regarding IP version 4 addressing goes something like this. Oh, they're the 224 to 239 addresses. And that's absolutely true. If we're going to be specific, we say that it goes from 224.0.0.0 to 239.255.255.255. I don't know how many that was, but you see the address there. And we can see these kinds of addresses reflected in host routing tables. There's an example of a snippet from a host routing table. Where we've got the 224 address space and then the mask applied of 240.0.0.0. But things are a lot more complicated than that. It turns out that there's a lot of reserved addresses in the IP version 4 multicast address space. So RIP, OSPF, routing protocols all over the place, they all have reserved IP version 4 multicast addresses. There's all host addresses, and the list goes on and on. For a complete list, you can go out to iana.org at this URL there, and they'll show you all of the reserved multicast addresses. So let's take a look at an example. Here is a standard address that we see used on IP version 4 networks all over the place. It's likely that if you did a capture on your own machine, you would see this address pop up. Not the source, but the destination. But the important thing that we want to worry about right now are the destination addresses. So I've highlighted the layer 2 MAC address and the layer 3. These two go together. So first off, we can see that the layer 3 address is in that 224 to 239 address space. But at layer 2, a couple of important things to remember is the fact that this thing begins with 01. And so that's a dead giveaway that you get a multicast address. But importantly, it's not just 01. It's 01005E, and that's a reserved heading for layer 2 multicast addressing. Now the 7F FFFA is a conversion from the last part of the IP version 4 layer 3 address. And that's why we say that these two things are tied together. When you see a multicast address, we convert that address and then add it in as a multicast destination MAC address. Well, how does that work? So we've got this conversion that we want to do from 239, 255, 255, 250 to that MAC address you see pictured there. So from RFC 1112, we find that the low order 23 bits of the IP version 4 addresses are converted. That means the addresses that have the least impact. And so for us, when we do the conversion to binary, as I've done here for you, what we care about is the rightmost set of bits. And so those are in red here. So I've got 23 bits. And if we convert those bits to hexadecimal, and so you can see that I sort of separated them here. We've got 111, that's a 7, 1111, that's an F, and then we just keep going. So we got 7F, FF, FA, and that's how you do the conversion. We put that in with that reserved MAC address. That's what we stick in there. Pretty straightforward once you've done one or two of them. Now IP version 6, as I mentioned earlier, has a lot of multicasting. Now, if you took a look at the IP version 6 videos that I did previously, I did a whole video on ICMP version 6, which is the neighbor discovery and all that. So we can see there's lots and lots of multicasting used in IP version 6. So how does this work? Well, we've got similar rules. We reserve an address at layer 2, and we're going to do a conversion. So we've got 3333. That's your dead giveaway that you have an IP version 6 multicast address. And so FF/8 is the reserved multicast address space at layer 3. So all layer 3 multicast addresses for IP version 6 will start with FF. And here is the IP version 6 registry. You can go out and take a look at all the reservations for IP version 6 layer 3 multicast addresses. Well, here's an example. The conversion is a little more straightforward. We just stick 3333 out front, and then we take the last 4 bytes from the IP version 6 layer 3 header and stick it in there in the MAC address. And so now FF02 in this example is another one of those reserved addresses. Now the colon just means that we have a lot of zero suppression, which means in this case we've got a lot of zeros that were suppressed, and that's why at the layer 2 MAC address we see 3 bytes of zeros stuck in there, because really that's all there was in the IP version 6 address. Well, I think that'll do it for our addressing refresher. If you want a little bit more, you can see the chapters that I wrote on Ethernet, IP version 4, and IP version 6 in the Packet Guide to Core Network Protocols. So that was the first book. Or you can take a look at the videos that are on this channel. I mean, I did a whole bunch of them. Next up, we're going to talk about IGMP. Thanks again for watching, thanks for listening, and may your packets always reach their destinations.